Good morning, one and all. Today, we are going to see a problem on economic load dispatch problem with a 3-unit system. So this is the problem. Determine the most economical units to be committed to supply a load of 6 megawatt. There are 3 generating units and the following data are given below. That is C1 is equal to 0.8 P1 square plus 22 P1. Next C2 is equal to 0.85 P2 square plus 21 P2. Then C3 is equal to 0.8 P3 square plus 20 P3. The maximum and minimum capacity of each generating unit is given as 5 megawatt and 1 megawatt respectively. So here 3 cost functions are given. Load that is total load demand is given, that is 6 megawatt. Minimum and maximum operating limits also given. So PD is equal to 6 megawatt and minimum and maximum generating unit is 1 megawatt up to 5 megawatt. So very simple. You can solve this problem within 5 minutes. That's all by using the lambda iteration method. Lambda iteration method already we have seen in our previous classes. What is the step number 1? To find out the lambda. That is lambda is equal to PD plus summation I is equal to 1 to n bi divided by 2ai, the whole divided by summation I is equal to 1 to n 1 divided by 2a. This is the formula for calculating the lambda. This formula already we have derived in our previous classes. So just what you need to do is you need to substitute. PD is given as 6 megawatt and here bi divided by 2a. So bi divided by 2a up to 1 to n. So n is number of generating units given is 3. So here b1 divided by 2a1 plus b2 divided by 2a2 plus b3 divided by 2a3, the whole divided by 1 divided by 2ai. So 1 divided by 2ai is nothing but 1 divided by 2a1 plus 1 divided by 2a2 plus 1 divided by 2a3. So substitute the values for b1 and A1. So here B1 what? So the general formulation, cost function AI PGI squared plus BI PGI plus CA. This is the general formulation. So simply here while giving the data itself, you just mark the like what is AI, what is BI like that. So you just mark here. So A1 here, this is a B1. The same thing you need to substitute. What is B1 here? Yeah, B1 is 22, B2 is 21, B3 is 20, A1 is 0.8, A2 is 0.85, A3 is 0.8. Just substitute all these values. You'll get the equation like this. Simplify this formulation. If you simplify, you'll get 6 plus 38.6029 divided by 1.8382. As I said before, don't round it off in your scientific calculator. Whatever the values after decimal, you just take 4 digits. I've taken the 4 digits here and I have calculated lambda is equal to 24.2644. Here, from this lambda, what is the next step number 2? Step number 2 is to compute the PGI. So PGI is equal to lambda minus BI divided by 2AI. So lambda already we calculated as 24.2644 minus BI. BI means for first generating units, BI is nothing but B1. For second generating units, AI is nothing but A1. So here you need to substitute what is B1 and 2A1. So here B1 is 22, 2A1 is 0.8. Just substitute and calculate the PG1 as 1.4152 megawatt. Similarly, PG2. PG2 is 24.2644 minus 21 divided by whole divided by 2 into 0.85. 0.85 is nothing but here 2A 2. So here is I is nothing but 2 here. Okay, so here 2A2 is 0.85. You just substitute the values over here and simplify using your scientific calculator. You'll get the answer as PG2 answer as 1.92 0.02 megawatt. Similarly, PG3 what? Here lambda minus B3 divided by 2A3. So this is B3. So 24.2644 minus 20 divided by 2 into 0.8. Simplify using your scientific calculator, you will get the answer as PG3 answer as 2.66525 megawatt. So here you need to verify the answer. So here you got PG1 as 1.4152, PG2 as 1.9202, PG3 as 2.66525 megawatt. So PG1, PG2 plus PG3 is equal to PD. That is nothing but 6 megawatt that is given in the problem. So you need to add all these things. I'm getting approximate 6 megawatt. That is 6.00. Some values I'm getting. I am getting. So that is approximately equal to 6 megawatt. So you need to write the conclusion also to get the full marks. So somehow it will be asked in the 5 mark means or 10 marks means you need to write the up to this. If you just stop, you don't get full marks. 1 or 2 marks they will reduce. So here you need to write the conclusion. So generating units PG1, PG2 and PG3 satisfies the load demand or power demand. And in the values what are all the values you got, you need to write, and minimum and maximum operating constraints that also you need to write. So here given in the problem, minimum and maximum generating unit is 1 megawatt PGA up to 5 megawatt. That is minimum and maximum capacity of each unit. They have given like 1 megawatt and 5 megawatt. So you need to write like this because they are not given for each generating unit. They have given commonly. So 1 megawatt less than or equal to PGI less than or equal to 5 megawatt. So you need to write like all generating units satisfies the minimum and maximum operating limits, and also it satisfies the load demand. Like that you need to conclude. This is how they will ask for your 5 mark question or 10 mark question in your semester examinations. Thank you.